This is a report partly on the workshop that we held on May 9th about using CDEs in data discovery, and also some thoughts about expanding what DataMed and BioCaddy can do with CDEs. So I'm going to do the first part, and then Ian is going to do the second part. So what I'm going to do is run through what I think the main topics of discussion at the May 9th meeting, and what some of the lessons from those were. The comment that came up most frequently at the workshop was the need to harmonize CDEs across repositories and domains. That currently there are something like 8 to 12 different CDE initiatives across NIH, and the National Library of Medicine now has a CDE repository which has put them all in the same place, but they haven't yet started the work of harmonizing so that you can tell when the same data element has been described by more than one repository. And that would save a lot of work. One of the key reasons it will save a lot of work is that currently it is very difficult to resolve CDEs if all you're doing is doing a text search. So Wa gave a presentation on doing searches for CDEs in DataMed, and the success rate of actually finding what you were looking for was rather low. What that really means is that we need initiatives like the CDE repositories so that resolution is done at the point where the data is created. Another thing that came out that as very desirable that has implications for DataMed is being able to search not by the data element but by the concept that the data element measures. And a number of the CDE registries actually do link their CDEs to concepts and sometimes to ontologies. If we had the CDE identifiers in DataMed that could be linked to the data, it would be possible to develop search strategies that would be based on those ontologies. Currently, when you talk to the NLM, and especially, but also to some of the other CDE registries, they think of CDEs as something that is being done for clinical data. In fact, NLM, I think the NLM repositories specifically has in its charge that it's about clinical data. But it was very clear at the workshop that people see CDEs as something that's valuable for other types of data as well. There are data elements that are CDEs that are widely used in other kinds of non-clinical settings, such as health interviews, like the Anne Haynes series, where they're using CDEs. They don't have any identifiers attached to them, but they're using the same questions that are being used in health interviews. So it seemed to people at the workshop that the clinical classifications have implications for other domains and even for non-human studies. One of the things that was that there's been a lot of attention to, and the NLM CDE repository has worked on quite a bit, is that data elements are often presented in the form of a form, a scale, an instrument that contains a number of CDEs. So for something like depression, there might be a 10 data element scale or a 30 data element scale that has its own name. And in terms of data discovery, that should be an object that can be discovered on its own. So in DATS, we need to be able to search for both the form as well as the data elements that are in it. On the data creation side, the NLM CDE repository has a tool for creating forms. The BRICS system, also created within NLM, also has that. And CDER, of course, is a creator of forms. The NLM repository raised an interesting issue which they have been dealing with, which is whether instruments that have a copyright can actually be exposed on their website. And they're very concerned about violating the copyright of one of these instruments. Lisa Lang actually talked about that and how they're worried about whether they can proceed. I actually looked up what ICPSR does in this same situation, and we about a dozen years ago confronted this and got a legal opinion from the University of Michigan lawyer who said that if we publish an instrument of this kind in one of our code books, that that is actually acceptable under the fair use doctrine of copyright, because we're publishing it for a limited version. And there is language in our code books that says that some of this material is copyrighted, and you can use it for interpreting the data that you've downloaded, but you cannot then take these same questions and make your own data collection instrument, which would be a violation of the copyright. So I think it's the NLM folks need to get their own legal opinion, but I think they're actually, for the purposes for the purposes of finding data is probably okay. There's some question about whether they can create forms out of these things, which is one of the things that they do. And finally, there was at the workshop a suggestion that one way to get researchers to use CDEs was to require them to mention it in their data management plans, and if the scoring of their grant proposals was affected by whether they use CDEs in their data management plans, we'd get a lot more compliance. So let me conclude with a couple of general observations. One of the things that came out at the workshop is that while there's a lot of activity around CDEs, the CDE registries, but especially the NLM repository, have been pretty much exclusively focused on the data collection phase. And they hadn't devoted much attention to the issue of data discovery, which is, of course, the way that BioCaddy comes to it. So it was clear we had a lot to learn from each other. And it was also clear that projects like BRICS, which is creating data collection tools, and CDER are extremely important because they lower the cost of collecting CDEs with CDE identifiers for researchers. Before I turn it over to Ian, I'll just make one more comment. I have had some recent correspondence with the people at the NLM repository and with Mike Huerta at NLM, where I asked them if there were specific things that they wanted to collaborate with BioCaddy about, and haven't had a response on that issue. But Mike did mention, what I'm sure some of you know, that NLM has created a task force internally to look into using DATs for their internal processes, and that's one of the things that Mike announced at the May 8th meeting. So NLM is very seriously looking at DATS for its future usage. So now I'll turn it over to Ian.
So what I was going to cover here, and these were things we looked at the workshop that George just mentioned. This, in a way, is trying to identify low-hanging fruit and trying to. There are a couple of examples here of data sets that we already have in DataMed where we know there is some kind of connection with data elements. And I'm going to broaden that term a little to include variables, because the word common data elements is heavily used in the clinical world, but maybe not in the preclinical world. And I've got one example here of the mouse phenome database where they don't call these things data elements, they call them variables, the things they're measuring, but they're essentially the same thing. So just a caveat there to, if you can have a caveat before you start, of the terms of reference that we're applying this to. So I'll come back to this slide at the end, so maybe you won't dwell on it here, but here were three areas from looking at this that seemed like initiatives for collaboration with NLM and with others who have CDE repositories. And as George indicated, there are a number of CDE repositories, and in some cases they're called metadata repositories as well. Organizations like CDISC maintain them. NCI manages one in the CADSR. One can look at the CEDA system as a metadata repository, where here metadata means not. So there's this one view of things that says I'm looking at sequences and all the other data, like the blood pressure, that's metadata, that's data about my sequence, whereas the sequence is being regarded as the data. Here, what I mean by metadata is where we would say, well, what's the name of blood pressure? What's the unit of measure for it? What's the definition of it? Some people would call that structural metadata. And that, when we talk about a metadata repository, like CADSR or like the NLM repository, it contains no blood pressures. It only contains data about what blood pressure is, its code, etc. So that's what we mean by a CDE repository or a metadata repository. So I'll come back to those, as I said. This connects very nicely with what Chris was just talking about using identifiers for data elements. We're using them for data sets, we're using them for other things. The proposal here is around we should be using them for data elements as well, and hypothesizing what prefixes are yet to be confirmed, but this is how you would take the identifiers that are used in CADSR and the NIH CDE repository and turn them into queries. And we have all the infrastructure in place, or prototypes in place, as Chris is indicating, to do this. It's a low-impact approach. Essentially, all we're doing is sticking the prefixes on the identifiers, on the front of the identifiers that those systems are using already. We just need to get organized about the prefixes and the registries and start using these things. So, next. All right, so the first example, this is how the Cancer Genome Atlas, or one of the 32 diseases that were done as part of the Cancer Genome Atlas, shows up in DataMed. This slide is just proving that we've got that study in there. This one is, as I said, there are 32 different diseases that were studied in the Cancer Genome Atlas. So this is kidney, renal, clear cell carcinoma. This, if you like, is what some people have been referring to earlier as drilling into the data. This is extracting data from the XML file about a patient to say, well, what's in there? and these are the XML element names, but all of these in that data set are annotated with a CDE ID, which we see in this column. If I wanted, I could click and link to that XML. These are example values that you would find in there, just to be clear what we mean by tumor tissue site. It's kidney here. Gender, an example of the value is male, vital status dead, etc. But all of these are annotated with an ID out of a metadata repository. And this is the metadata repository. So if we were to follow one of those, and in this case it's something called the Karnofsky Performance Score, and this is in that CADSR CDE repository. And I'm not going to go into all the functionality that CADSR offers on that, but there's rich information about that measure in there. It is also, the Karnofsky Performance Status Score is also present because it's been imported into the NLM CDE repository from CADSR. So the point I'm trying to make here is we've got low-hanging fruit here is we've got these data sets in DataMed, and we've got this information about data elements in two of the metadata repositories that we're talking about. So the low-hanging fruit here is there's a connection waiting to happen. Just a bit more information. I'm trying not to get too Monty Python about this definition, to look at what the Karnofsky Performance Status Score is. It's basically, and it's the result of different ways of surveys to measure it, but it comes up with the codes refer to dead, moribund. There isn't one for bereft of life or pining for the fields. I don't see either of those there, sorry. It just is too close to home. But the rich metadata repositories, and these are all cross-linked to codes in the NCI thesaurus. So we've got data potentially. What we're not extracting at the moment, going back to here, is out of that file about these patients, the information that we know which data elements. Now, we would have to drill into this XML file to do it. And if you drill into that XML file to do it, this is just a point about CADSR. This is the API for CADSR. So this data isn't available in a machine-readable form as well. If you had that ID, you could go to a link that would bring you back this structured information, some of it more than you would wish for, perhaps. But you can see its long name is the Karnofsky Performance Score. You can see who modified it. Its definition is there, etc. So to take that one disease of the 32 diseases, the summary of the known data elements in that data set is we know there are 77 clinical data elements, common data elements, clinical common data elements, and 55 biospecimen common data elements. But there's a similar picture for the other 32 diseases that we have in TCGA. And so this is sort of sitting there waiting to be mined. We have the slot in DataMed, the dimensions, where that information could be put. But it's also richly cross-referenced to both CADSR and to the NLM CDE repository. So the other example that I was going to look at, and this is if that's the clinical example, here's the preclinical example, and no one will mention the words common data element in relation to this, but essentially we're dealing with the same thing. So we have in the mouse phenome database, which again, here is how it shows up in DataMed, it just to prove that it's there. Here's one study that's in the mouse phenome database. It's a study on using the drug imipramine, which is an anxiolytic being used as a test case to look at the So different strains of mice, they want to measure them for the extent to which those genetically engineered mice may or may not have increased susceptibility to depression. Okay, so is depression in a mouse the same thing as depression in a human? Obviously not. But we use mouse models. This is not a debate about are mouse models relevant to human data. It's science, okay? We'll let other people argue about whether the relevance or not. But fortunately, when the mouse phenome database was ingested into DataMed, these dimensions were discovered, things like the average center time, the distance traveled. Now, I know no more about these than you do, so don't let your ignorance about them deter you, other than knowing that, so we can make a connection, right, between the number of fecal pellets that you might find in a mouse's cage. You can extrapolate that might have something to do with how anxious those mice are. But that's what these data elements are, but they're a level down from being a measure of depression, or it's not signposted as a measure of depression or a measure of anxiety. What is also interesting is that there in the mouse phenome database, and this connects with, I think, a point that was made earlier about the methodologies that are being used. The mouse phenome database categorizes, these are the instruments, if you like, and here we're talking about an actual physical instrument like an elevated plus maze. Those are the instruments that are used to measure depression or anxiolysis in mice. And it takes us to this idea of, because something else we've been talking about within BioCaddy is the idea of an ontology for data type. And we're going through discussions around what data type means. But it seems there is a spectrum here which the mouse phenome database is kind of dealt with in some sense, and is recognizing that there is this sense of a data type, which, for example, here might be behavior, but then there are particular instruments which might be a light dark box for preclinical data, but it might be a case report form for a clinical study. It's not by coincidence that the word instrument is used in clinical research and in social sciences research in place of the physical instrument that you might use in a preclinical measurement situation. And then finally, you have down to the data element or variable, which is, that's where in this kind of, when you see these, you can't see the wood for the trees in a way. What is distance travel, first trial, duration 5 minutes? How do you extrapolate that to something meaningful? So there's this spectrum that it seems to be important to recognize, and here's an example of how a database like the mouse phenome database, so this isn't talking about data elements, is dealing with this. They've organized their data into different categories. So here are the behavioral related. So this is all of the data. This is fantastic. What if we could do this for humans? This is all the data in the mouse phenome database about this strain of mice with this hieroglyphic identifier. And look at how rich that is. We know about the behavior of this strain, we know about its hematology, we know about its reproduction, we know about its immune system, and there are data sets about all of that stuff, and we know what all of the things that we've got one of the points here is we've got an opportunity with human data. Just as it's easier to do mouse experiments, it's easier to get that sort of broad spectrum of data from mouse that we love to get in human, and to be able to make the connections between Just as we use mouse biology as a model of human biology where appropriate, and with the caveats that go with that, one can use handling mouse data to learn something about how we might handle human data. So I'm going to skip through those. Yeah, so here's where you can go in and just to make the connection. Yes, we've got that number of minutes that a mouse was able to stand on a tightrope. Okay, but maybe in some way, let's extrapolate that to something meaningful. The concept here might be the same as the concept that comes from a case report form that purports to measure depression in humans. So conceptually, we can be linking both of these instruments to the concept of depression. And that's not something that DataMed would do on its own, but that's something that you would find out of a metadata repository like CADSR, which will link measures to concepts. This was briefly a summary talking about that low-hanging fruit. Maybe this is more extensive than this, but this was a quick summary of where we've got data in DataMed, where we know that there is data in different metadata repositories or CDE repositories, and identifying which ones. The other one we've talked about that I haven't covered here is dbGaP, so that's the only new information on that slide. So that comes back to the summary of the suggested initiatives. With this low-hanging fruit, can we show the value of linking to a CDE repository? Just getting over the fact of how we work with identifiers for CDEs based on the scheme that Chris has described around how we identify anything. And the last point is there's a symbiosis here. The data discovery indices probably shouldn't be setting out to do these data models of metadata, where metadata is what I referred to it as earlier as is the structural metadata. And the symbiosis between a data discovery index and a CDE or metadata repository, the data discovery index is more the customer of those repositories and relies on those for the rich information that are contained in those. Okay. So questions at this point for George or myself?